In this exercise, we're going to exercise the notion of a standard form of a quadratic function. Let's read the problem. Write an equation of a parabola with vertex at the point 1, 2, which passes through the point with coordinates 2, 3 halves. So there are 2 points in this problem. One is a vertex of a parabola, and the other one is a point through which the parabola passes. So let's see where those points are. First, the point with coordinates 1 and 2. So its x-coordinate is 1. So if I drop a perpendicular from the point to the x-axis, this will be the number 1. And this here would be the number 2. And then we have the point whose x-coordinate is 2. So that is 2. And its y-coordinate is 3 halves. So here we have the number 2, and here we have the number 3 halves. 3 halves is of course 1.5. Okay, so here are our 2 points. This point is the vertex, and this is just a point through which the parabola is going to pass. Now, I claim that entirely from the picture, you should be able to determine whether the parabola opens up or whether it opens down. So, suppose that we've already solved the problem. Can you guess whether the final answer is going to be a parabola which opens up, like an upside cup, or a parabola which opens down, an upside down cup? Which of the two is it going to be? I'm sure you guessed it correctly. We're going to get a parabola which opens down. Why? Well, because this is the vertex, so that's the vertex would be the lowest point if the parabola were to open up, and clearly there's another point on that parabola which is lower than the vertex. So that can only happen if the parabola opens down. Its graph should be something like this. I'm freehand drawing here, something like that. Okay. By the end of the problem, we'll draw a computer-generated plot of our function, but for the time being, we should expect to, with hand, I could predict that I should be getting something like this. Okay. So, suppose that we have solved this problem, and we have gotten our quadratic function. Well, once we have our quadratic function, we could use completing the square to write that quadratic function into a standard form. So let's say that we know the standard form of our quadratic function. So our quadratic function is of the form y equals a times x minus h squared plus k. So if we could solve the problem, we could certainly also find the standard form of the quadratic. Okay. Now, let's see what's given to us. We are given that the vertex of the parabola has x-coordinate equal to 1 and y-coordinate equal to 2. But if you remember, the number h in the standard form of a quadratic was exactly equal to the x-coordinate of the vertex of the parabola. So the number h must be equal to 1 and the number k must be equal to 2, right? So the number h must be 1 because that is exactly the x-coordinate of the vertex, and the number k must be equal to 2 because that's exactly the y-coordinate of our vertex, right? So h is 1, that's the first coordinate here, and k is 2, that's the second coordinate here. That's this point. Okay. So, using very little information, using only where the vertex of the parabola is, we've already figured out a lot of the parameters of that parabola. In fact, in order to know which parabola we're looking for, all that's left is to find what's the value of the number a. So if we know a, we know the parabola. Okay, let's see what's a equal to. How do we find a? Well, we are given more information. We have not yet used the fact that the parabola passes through the point with coordinates 2, 3/2. How can we use that in this problem? Well, if our parabola passes through the point with coordinates 2, 3/2, that means that when I replace the number x with the number 2, this number, and when I replace the number y with the number 3/2, I should get an equality. So I need to have that a times 2 minus 1 squared plus 2 must be equal to 3/2. Once again, the numbers that you see here, 2 and 3/2, those were the x and y coordinates of the second point through which our parabola passes. So now this is a linear equation with respect to the variable a, and it is relatively easy to solve. Indeed, 2 minus 1 is equal to 1, and 1 squared is equal to 1. And 1 times a is equal to just a. So I can remove that. So 2 minus 1 squared is just 1, and 1 times a is just a. And I can transfer 2 to the right hand side. Of course, it acquires a minus when transferred to the other side of the equality. And finally, 3/2 minus 2, that equals negative 1/2. I have found my number a, and so I know the standard form of my parabola. So the standard form of my parabola is y equal to negative 1/2, that's a, so negative 1/2, times x minus 1 squared, so 1 is the number h, plus 2. So we have written an equation of a parabola in standard form. Now we have our answer in standard form, but can we give the equation of our quadratic into the usual form? So what other equivalent answers we could give? Well, we could of course take that quadratic, uncover all the parentheses, and transform the quadratic into the form ax squared plus bx plus c. Let's do that. It's not required by the statement of the problem, but it makes sense to do that so as to see the various equivalent answers that we may produce for this particular problem. So we have negative 1/2 times x minus 1 squared plus 2, and I can simplify that to negative 1/2 times x squared minus 2x plus 1 plus 2, which simplifies further to negative 1/2 x squared plus x minus 1/2 plus 2, or finally I could rewrite that as I run a little bit out of space, so let me continue over here. Negative 1/2 x squared plus x, 2 minus 1/2, that is negative, that is plus 3/2. Okay, and that's my final equation. Negative 1/2 squared, negative 1/2 x squared plus x plus 3/2. And as you can see, this parabola has a negative leading coefficient. So as promised, it's a parabola that opens downward.